Okay, my outstanding friends, this is going to be fun. This is Fermilab, and it's going to be a public lecture by Dr. David Kaplan from Fermilab about dark matter, the next frontier. I'm going to show you my research, and then I'm going to explain to you what they think about dark matter. Okay, my friends, before we get started, I can see individual light photons using CMOS. This is fully understood. It's well known now, and it was understood in 2014, but nobody would accept it in the scientific realm because they were told, no, you're never going to be able to see it. Well, it's quite obvious, and I will show you these photons, and then I will show you dark matter. It's because of the dismissal and the refusal to investigate that we've missed all this stuff. Okay, couldn't be any simpler than this. When the atomic bomb goes off, this is atomcentral.com. When the atomic bomb goes off, the first thing that happens is all the white particles go out, and they will burn everything that's burnable, anything that can combust. Then the black particles will come and knock everything off. So here it goes. And I got to run it at 25%. The first thing you're going to see is extreme white haze because everything is being excited. All the atoms in the air, all of the molecules, boom. You see that? I stopped it. All the particles in the air are being completely absorbed by these electrons. And all they are is the white electron part that's hitting now. And then everything just burns up. There's no movement whatsoever. It's just combusting. I stopped it again. And even the wind doesn't even blow it. Just barely moving the air. But the particles, which have no mass, are infusing into all of the other particles that are in the air and forcing their electrons to be liberated, which creates an enormous amount of heat, which creates this burning effect, but no push. Now I'm going to keep going back to it now. It's just going to combust. It's just combusting. Everything that's combustible is now gone. It's all gone. Now comes, boom. It's running slow. That's what it sounds. Now it's all turned around and coming back. So what do we see? Let's look one more time. Here's where the bomb goes off. And all we're seeing is the smoke because everything has been accepting extra electrons, which creates heat. Electrons are heat. The more electrons you put in, the more heat. Now comes the particles, which are the dark particles, and they push the house away. They don't burn it. Then everything turns around and comes back because we have a void where it blew up. Okay, my friends, so here is my claim that this is dark matter, that black dot right there. And we see it all the time in our experiments. You see this here? The black and the white together. That is light. These are photons of light. You can see photons of light. They have confirmed this with CMOS. It's being done right now everywhere. Okay, you see this? This was all done with lasers, just cheap lasers and a Venturi and a cell phone using CMOS. Very well understood. This is the particles that we found, and this is the particles that CERN and Fermilab found. They do exactly what we discovered they do. The black is the carrier and pusher and sucker. This is the glower. You see it glow like crazy when it concusses? The black one just goes on by itself. You see the black one here? Watch. The black one just stays sterile. They call it sterile muon. The electron goes into the electron shower mode. Exactly what I showed. And this is light accelerating. So we got a lot of problems with physics. And they're refusing to engage with me, even though I show this in absolute, undeniable proof of these being the particles they're looking for, which they found, we found them too. Now, not only did we see them in the photon phase, we can see them in the neutrino phase. This right here is the neutrino phase. Let me turn the light off so that we can maybe get a little bit better contrast. All right, oops. Sorry about that. Everybody okay? All right, now, this is the neutrino phase. You see this right here? This is the same photon. This one picture takes because I mean it's light. How many, you know, you're getting zip all at one shot. And we have other ones where there's a very, very long line of particles we can see. But this is very focused, and we're seeing the neutrinos. These are neutrinos too. They're not quite fully formed photons. The fully formed photon is coming because it's concussing right here and going to explode. The other ones don't have as much extreme concussion. But these, you see these black and white, black on top and on the bottom and a white in the middle. This has got almost four, the two and the two, like this does. But they haven't formed fully yet. They only form fully if they're going to end up being exploded, it looks like to me. So here's the neutrinos. There's the fully formed photon. The only reason they continue to change flavors and masses is because they're stacking up on each other. And they're weighing more and more and more as they push harder and harder and harder against each other's field. It's as simple as that. Here they just divide. They go on their separate ways. And we have this in the green as well. So it's not just a one-off. Here it is right here. And here's the neutrino values of the green. The green is much faster. Well, when I say faster, here's what it does. Here's the green and the red at the same time, both lasers going through the same slit at the same time. The red just gets pushed out of the way. The green actually reconcusses out here. But in the meantime, they sort of swirl around together. You see this? They're swirling this way. That normally doesn't happen. Normally they're straight up and down and they go this way. This one's going that way. That's a tumbler, because this white is pushing the white of the green particle into a spin. Normally they don't do that. They spin together around with the axis of the Earth. That's why they have upspin and downspin. It's just because they're polar. They're polar particles. They get attracted to the Earth. Now, these are our Higgs fields. This is what they're looking for, Higgs fields. And they have it opposite. Higgs fields don't decay into particles. Here, let me show you what they say. This is kind of hard to understand, but here's what they do. They say that the Higgs fields decays into these particles. Well, that's incorrect. These two particles here are the only two particles that exist, the white and the black. When they hook together, they form the Higgs. Not the Higgs breaks apart to form these. The Higgs is when they attach together, they form this. Now, these two particles, the white and the black, together make a gluon. Two gluons make a photon. All the rest is nothing but variations of this. The neutrinos are stacking up on each other. I just showed you. That's why they have different flavors of different energies. The upspin, the downspin, all these different strange and charm and the bottom, and they really don't understand what's going on at all, because they don't understand that everything is made of a dipole. There's nothing but dipoles. All right, here they are right here. Here's the dipoles. There they are. That's light. Now, if I'm working in light and they're working in protons, they can't understand anything, because all they're doing is digging through trash, literal trash. We're actually watching them develop through the neutrino phases into the photon phase, into the sterile muon and electron shower phase. We did it all right there. Done. Just to add a little fuel to the fire, this is CERN's and Fermi Labs' idea of the muon and electron neutrino attached together, the white and the black, and the muon goes sterile all by itself. The electron goes into the shower mode. Precisely what I show you right here. There's absolutely no question this is what's happening. The only time you can see the black is when it's on top of the white. It obscures the white, because the black will not allow the white to come through it. But the black will not emit, it will not absorb, and it will not reflect. And the only possible way of seeing it is when it sits on top of the white. And we can see it here all over the white. We've divided the black from the white, and the black is a pusher, so it's slapping that white through there. And I can prove that too. And then on the other side, this Venturi has no black coming through whatsoever. Not a single taste of black. It's completely separated the black on this side from the white going through. There has to be extra black particles, which is the dark matter. It has to be laying around all over the place because they immediately reattach to this white over here. They didn't jump from here over to there. So there has to be black ones extra laying around to grab onto these white ones. That's the only possibility I can see. And that would account for the fact that they believe there's more dark matter than the white matter. Light spins. That is a drill bit. It's a spinning particle. It's a right-hand spin. Some goes over this way, some comes under and goes over this way. This is a single slit, not a double slit. We don't have any waves flapping over each other and all that stuff. This is a one slit over this way. Sometimes it goes this way, sometimes it comes over and goes that way. But the white particles do not want to be next to each other, so they set up these, what they call interference patterns. They push this one and push that one. So they say, I'll stay in my lane, you stay in your lane, you stay in your lane. You know, they're pretty accurately staying in their own lanes. But you can see, you know, they slurp around a little bit. Well, I have better shots of it to show you, and I will later. But this proves that the black is pushing the white. And I think I have or will show you the atomic bomb blast. There's no question. The white hits first, and it just burns. It has no push value, no mass. All it does is invade electrons and just, it has no mass. But boy, I tell you, it burns like crazy. And the black has no burn, it just has mass. Totally the opposite. So you could call them matter and antimatter. That's fine. It works for me. And this one allows a little bit of the black through. The other one has no black coming through at all. So this shows you that the black is pushing the white. Before, the black pushed the white to here, and the white was the only thing one could get through, and it just gets slapping the hell out of it through, squirting it like a tube of toothpaste through the other side. We can harvest that, I'm pretty sure, because this is supposed to be absolutely enormous amounts of energy. When you can create electron showers, you are up in the multiple billions or even into the trillions of electron volts, which is staggering. From here, from millions to go up to billions is an absolute enormous amount of energy increase. And if we can harvest those billions, we got free energy. Okay, so I claim we may be able to get free energy. This is just a possibility. It has to be engineered and figured out a little better. But I don't see any reason, if we're using megavolts, electron volts here, and we're getting billions of electron volts here, that's an increase in energy. What we have to do, though, is be able to harvest that. Having an increase in energy is fine, but if you can't harvest it, it's just nothing. And right now, it's nothing because we can't harvest it. What do we need? We need to be able to come through, send that laser through with those black and white balls, and then from here, coming through, we end up just getting the white. Not this one, but this just shows you that we can push those particles, and we are pushing them like crazy through that Venturi. I mean, just scattering them, scads, thousands, billions a second. And they're coming through here, and if we can send them, slap them down through a photodiode, which once they get through that gate, they can't get back. And bam, 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 swish, 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 swish. We're collecting energy every time that pulse comes. We can regulate the number of pulses, we can regulate the intensity of the lasers, we can regulate the Venturi, we can change the transition metal collectors, which silicon, you know, the standard solar panel now is not going to be extremely efficient for us. We need transition metal collectors, which means very, very thin films of transition metals, which all have different energy levels. So they will absorb all of the white particles, which is all the different colors. We only have monochrome here, you know, a single color, and because we're only using red, green, and blue lasers. So that's why we see only red here. But if you were working with CERN's particles, you're going to see all the colors, because they're smashing protons, so they have all different energy levels. We only have one energy level of red, or green, or blue. So that's the difference. But when you want to harvest it, and you want to use a white light, because now you got all kinds of energy coming at you, a white, brilliant laser. And then, but you need to be able to harvest all those different frequencies. Because if you can only harvest one frequency, all the rest of them just wasted. So we need these transition metals. And they're starting to understand that thin film transition metal photo receivers, basically, is what it is. Now, if we can harvest that and increase what we sent out here using, say, 5 watts of energy, and we got 200 times more coming through, and they claim that's not out of the reason. That would give us 1,000 watts. That's 995 watts of free energy. However, we have to recoup it. If we could recoup 30% of it, we still got 300 watts. From 5 watts to 300 watts is a hell of an increase. Why can't we use this energy? We know we're going to get an increase in energy. Anytime you see an increase in brightness, you have increased the energy value. That's what flames are. That's what burning is. That's what explosions are. That's what these head-on colliders do. All you see is brilliance. Anytime you have brilliance and illumination, you have an increase in energy. And that, my friends, is an increase in energy. And this could house thousands of these. These lasers are so tiny. I mean, here, these are the kind of little tiny receivers. The lasers are going to be so tiny, you could, and you could have thousands of these inside of a box this size. And every one of them producing a ton of white particles. You should be able to power a house, a car, boats, anything you want. Go out in the woods with this, give these to people in the woods and living in rural areas that have no stable power supply. They're not, this is off the grid stuff. You carry this around. And if we can do this, and I think we can, all you need is a regulator in here to say, I want 220 volts, I want 110 volts, I want 50 cycles, 60 cycles, AC, DC. Once you push that electricity in there, those electrons, do what you will, my friends. It's free electricity, and I don't see why we can't get it. But they have to start looking at what I am explaining here. And I have been pushed out of the realm, so it's very, very hard to get acceptance. Somebody's going to have to stand up and speak for me, because my voice is totally suppressed at this point. Okay, I have shown you that the particles can separate, and from the showers, they turn into the electron showers and the sterile muons. Now, here is what CERN and Fermilab do. They hit particles, gigantic particles, head on. Why do they have all these different colors? See, this is from CERN. This is a head-on collision of 2 gigantic particles. There's hundreds of billions of particles here colliding together, and they just throw off all this, literally, debris. That's all they're looking at, is debris. Now, some is red, some is blue, some is green, some is yellow, some is white, some pulses. This is what they see. What they're seeing is the red is the very lightly attached particles way out on the outside of the protons that they're shooting. Inside, the very tightly attached ones, they have to come out blue, because they really got to stream out of there, because they're very tightly attached. The same thing with the yellow and the green and all those other colors and the white, because they are right down in the core. And to pull them away from that black, you really got to smash them. The red is sort of just laying around the outside. Now let me show you what we did. This is our Higgs fields. All right, these are real. Now that's where that white particle comes through, just in its own stream, and creates all of that. These are only one color. You see, there's where all the different colors. The only reason you're seeing these turn a little bit bluish and purple is because they're being pinched. You see that? That's being a pinch. Color is nothing more than compression. Basically, color is compression. And I can show you another shot, because this started, all of this started out as 100% red. It should have all stayed red. Watch this one. See this one? Look at that blue one. This came through, splashing again, the white, bam! These fields crushed that blue one. Well, it was red, but it crushed it in its these two fields came in, and their magnetic fields crushed together, and that got caught in the middle, and it turned blue because it's being starts screaming, I'm going to turn blue, and it did. Okay, you're going to say, oh, Roger, how'd you get these images? Very, very simple. It was done with this laser through two finishing nails, very, very tightly close. Shot that through and picked up this light with the selfie side of this phone. You see it, Samsung, right there? This is the same phone. This is like from 2013, 2014, somewhere around there. 2015, we were deep into this, showing all of these particles. And everybody was screaming, no, you can't see them, you can't. I said, yes, you can. With CMOS, all we're seeing is what's given off is high luminosity. And now CERN shut down to add CMOS to be able to see these. I went to the University of Geneva. I told them, here's what we're doing. We're focusing and we're using CMOS to see these particles. At first, there was a little bit of pushback, and then they stopped pushing back. And then I found out they shut down to focus and use CMOS. And that's what they did in 2022. They opened back up again, and they are getting much more collisions and being able to see the particles much better. I am not unknown in this field. I've been doing this for a very long time, and I understand this very, very well. I am just pushed back, and at this point, I'm not unknown, I am just undiscovered. This is a discovery worth being investigated, and it won't even, they said from Fermilab, we won't give you 1 minute. Don Lincoln is the one. Now, I hope this other guy will engage. You're seeing what I'm showing you, and if we could get free energy, and for them to just deny me even to talk to me, that's just disgraceful, really. So I hope this guy won't be like Don. You know, that goes back a long time with Don, and he was very obnoxious to me, so I was very obnoxious back. I can be very obnoxious. So this is what happened, and I have experienced this right across the board with academia. You do not invade their territory without extreme consequences. I don't get a lot of extreme consequences. I don't care what they think of me. I don't need their grades. I don't need any of their money. I'm ready to expire anyway. So to me, this is just truth, and I see very little of it in our educational system. Very little. It is dominance, dictation. You know, they're dictators now, and don't you cross them, or your life will be destroyed, and they'll keep your money. So tell everybody you're an idiot because you couldn't repeat what they told you to say. It's really gnawing at me very deeply. So hopefully this guy will pay attention, and maybe we get some free energy. Maybe we could help things. That's what I'm trying to do. I'm not trying to step on anybody's feet. Okay, as I mentioned before, we need a good solar collector here, and a transition metal thin film solar collector, which would be collecting high amounts of energy. Right now, as of 2023, they've gotten it up to 47%. That's huge. That's almost half of all the power that's hitting it, they're absorbing. Now, the thing is, this is very thin film. It's just like the old photo films they had. They would reel to reel, you know, they'd have a reel here and they're going, and they'd shine the light through it and they'd see all the pictures, the old style, you know, Cinevision or whatever they called it. But what's going to happen, here's what I would like to see done, because that stuff will wear out. The thin film is going to be good for a certain amount of time, but it's not going to hold up a real long time. Like these solar cells, they're made to last quite a long time. This will break down, depending upon the intensity of the laser and so forth. However, not instantly, and not over a course of probably days or weeks. However, if you could put like a roll here, and a rewinder down here, over here, let's say, and have that film going through here, and every week or something it would advance one little click and put new film here so that the breakdown wouldn't destroy it. All right, and the next week it'd click again and it'd wind up over here and it'd feed from the good stuff over here. And then the bad stuff, maybe every couple of years or something, you'd have to put another film in there, but it should be very, very, very simple. If it works, again, I don't know if it'll work, but I'm going to tell you what, when you read what it says, what an electron shower does, as far as energy goes, and that is electron showers, there is no question about that. And if it does what they say it does, well, we should be good to go with something like this. And inside this little box that I showed you before, you should be able to put thousands, literally thousands and thousands of these lasers with collectors right behind them. You might be able to have one big sheet coming down and have a whole batch of lasers going right into it, and that sheet feeds down into the photodiode. Something like that. Somebody could engineer this. It's going to need some engineering, and I'm not 100% sure it'll work. But when I see the kind of increased energy values, I can't see how it shouldn't work. Okay, here's what they were hoping to do long ago, was photon colliding, hitting head on. You don't have to do that. What you're doing when you're hitting them head on is crushing the fields that surround them, boing, like that. Well, they just go this way or that way. They won't hit head on and just go straight into each other. However, if you force them into a venturi and force them with that black matter pushing them through, they can't come back through the black matter. The black slams them through the venturi, separates them out. That's what photon collision should be. We're colliding the dark matter and forcing the white particles through the venturi. So that's what they missed. They couldn't figure out any way to photon collide. So they had to use big bundles and all kinds of magnets and all kinds of things, crazy stuff. This was proposed back in 1978. They wanted to do photons because that's the smallest particles. If you could already get down to where we are with the smallest particles, there's not much more to do. We showed it after that. We broke them up. They first tried to do this in 1978. They couldn't figure out how to do it. So they kept doing this 100 billion particles smashing together and only seeing 25 hit. And then when they see the 25 hit, all they have is debris. We see the particles accelerate, the neutrinos, the photons, the sterile muons, the electron showers. We see everything. The Higgs fields, we see it all. And we can do this 24 hours a day. There's no bam and it's all over for the next week. They get one big collision and they think it's fantastic. Oh, we saw this. Well, that's fine. We could do this all day long, all day long. And I don't think, if we did it correctly with the right kind of materials and the right lasers and the right thin film receivers and engineered it correctly, I think it could be a handheld device that you could carry around with you and have all the energy you need. Like the old Sumerians used to carry these pocketbooks around on them. Who knows what was in there? Okay, my friends, this took me a little while to figure this out, but I think I've got it pretty well figured out. Electron showers are the things that I showed you, which is all that white juice coming through there. Now, this is the physics for this, but they don't know how to do it like we did with light. So they had to start with protons to protons. So they hit proton-proton collision, create all these what they call hadrons, and then when they start to decay, they can see the neutrinos and antineutrinos of all flavors. Those are the ones I was showing you, those little bars up and down, sideways. And then they see the electron and muon neutrinos. This is when they take these energy interactions in the phasor, and they see 100 giga-electron volts to a few trillion electron volts. Now, what is a phasor? This is the new thing that they developed here. Now, this is not hard to understand. When I looked at it, I was very, very confused. But read what it says here, 100 meters of rock. What the hell are they doing with a rock? Well, here's what they did. They accelerated these particles, and they are complete particles, the black and the white. And what they did was they separated the white off and smashed those black particles into this rock. And all it did was go bam, 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 and slam. And it's just like, you ever see those magnet balls where they let one go here and it goes bang, and goes that way and comes back, and they go each way, this one and that way and this way. This is the same thing. They bang. And at the end, they create a big cavity here, this phasor. and they put these emulsion plates in there, and they see what these light particles, because they're going to be, the white particles are going to be the end result of these slamming into these 100 meters of rock. It's just a vibration, but it will spit out electrons. They spit through here. And here's what they see when they spit through. They see the same sort of stuff we see, these splashes. These are the electron showers. And then they record the energy values of these. It gets kind of complicated. And these are the layers. These are the electron showers, and these are the muon showers. The muons stop, and then they trail right off, the black ones. The white ones come through, and they shower way up, and they get lower energies down here, higher energies up here. We want to harvest right about here. This is not, you know, there's a lot of thinking to do. I tell you, this was confusing when I first saw it. But it's exactly what we're showing. Only we're doing it with light. We don't have to go proton, proton. This is the electron shower physics preliminary report. This goes back to 2021. So these things move at a glacial pace in physics, trust me. We're ahead of this game, way ahead. And we're using light, which they wanted to do in 1978, couldn't figure out how to do it. And they don't want to know how to do it now. It appears to me they refuse to look at it. Very, very distressing. All right, so they're just saying, we know all these things. These are all the things that we know. Those are not known.
It's relatively uniform on the largest scales. There's stars and galaxies and lumpy things in it. But it is, over the entire universe that we see, quite evenly distributed.
That's also not true. There's galaxies all over, and there's very, very dense regions in space. You know, it's not totally, you know, one area has all the matter and one doesn't have the matter. The thing is, you have to have light coming through that. They don't take that into account at all.
And that not only includes the stuff, but the laws that govern that stuff seems to be the same everywhere. And what is it full of? It's full of galaxies and stars, but at the fundamental level, it's full of matter and the things that make up matter, and photons, which are what we name particles of light, and neutrinos.
All right, I'm going to try to leave it right here because I can see where he's going with this. They're not going to address the particles that are in space. And when I show you the things that are in space, there are so many fields out there, and every field will affect the field of every particle that has to pass through it. That is absolute certainty. Again, this is strictly with a cell phone. These are the fields that are emanating from some spinning dipole in space, and it's creating these concussive fields, and they diminish over the course of time, but when they're very close to the source, they're and then they come out to here, and that's it. That's what a magnetic field is. Any particle that passes through that has to go through all that stuff. It's as simple as that. This is the moon. The moon doesn't have a field. The reason you see these stripes through here, this is from some other field, from another, whatever it is, I don't know. It's just some strange stuff out here. Anytime you see light, that means there's some kind of energetic reaction going on out there. These are either on the moon or they're between us and the moon, whatever that is. And that, whoa, and that, yikes. But everything is a dipole and everything is fields. When he talks about, well, they all talk about the speed of light is consistent, 186,000 miles a second, ridiculous. That's totally wrong. It continuously slows down. That's the redshift. It's not that the planets are flying away, which is the expansion of the galaxies or the expansion of the universe. That's just not right. So they base everything on this Big Bang. Everything started from nothing, and then it turned into everything, and then, you know, it goes on from there. It's just, really, it's crazy, to be perfectly honest with you, but that's what they say, and that's what you have to say back, or you will fail. Okay, let me just explain to you something. They disregard all this stuff in space and say that the speed of light is not affected by all this stuff. It's really complete nonsense, to be perfectly honest. I can't imagine how they came up with that interpretation, because they say Einstein says it can't slow down. We know now, no question whatsoever. It's been proven 100% it slows down, and it stays slowed down. It doesn't speed back up again.
Now already been seen using gravitational lensing. So we've already now starting to see the structure of the dark matter, whatever this matter is, that lives underneath the visible stuff, which is...
That's exactly what I've been saying. The dark matter is completely encased by the white stuff that bounces back at you. The dark matter is the gravity. It pulls everything in. And it's a complete coating around all dark matter, which is the gravity, which is the muons, and it pushes the white matter.
Is the stars, galaxies, and the gas contained in them. And dark matter is something else. We don't know what it is.
There it is right there. They don't know what it is. I just showed it. So I want to be engaged in a discussion of what I show using light, not using protons, using light and crushing the fields exactly like if you hit them head on. There's no difference whatsoever to crush them sideways. There's absolutely no difference whatsoever. You're invading each other field. The same thing when you hit them head on. If you're an invasion of a field, no difference whatsoever. Only we can do it with light, they cannot. Okay, I have a different interpretation of the atomic structure and so forth. It's called Electron Dipole Flood Theory. And all electrons are dipoles. They have a black and a white. The Muon and Electron Neutrino attached together. They're called a gluon. We would have always called that an electron. But they travel in pairs. And the black part is the part that pushes the white part or pulls the white part. I'm not sure which way it works, but it works. They want to be attached together in the most extreme, strong way. So when we break them in our Venturi, they want to come back together extremely attractive. That's where your energy source comes from, is that electron flowing to that dark matter. And we can separate it out. I don't see why we can't collect it. Okay, I left a message up here. We did exactly what they're trying to do, and we used the CMOS, and I would like to discuss this with Dr. Kaplan. So maybe you could come up here. It's called Dark Matter, the Next Frontier, public lecture. This is Fermilab. Maybe you could leave a note. Please talk to Roger. He seems to have done some research, and he'd like to engage. And I'm going to try to contact him myself, but I really have never had anybody respond. You know, I've tried really hard. I got to be honest with you. I really tried hard to engage, but I am just outside of that realm. They don't like the things I say because they're not the things that they say. And I don't see that as being real scientific. Now, I'm hoping Dr. Kaplan is a real true scientist, because then I will hear from him back, but let's see.